Let A be the vectors A1, A2, and A3. Let W be the span of A1, A2, and A3. How many vectors are in A? There are 3 vectors in A because there are 3 columns. This is one vector, this is another vector, and this is the third vector. Is B in W? That's the same as asking, is B a linear combination of A1, A2, and A3? Another way to say that is, if A were written as a system of equations, is B a possible solution? These all are saying the same exact thing. So to solve is B in W, we will write A and B into one matrix and then put it into row echelon form and see if there's a pivot in each column. So here's our matrix with A and B both in it. You can imagine there's like this dotted line right there, because this column right here is what these will equal, if that makes any sense. If this were written as a system of equations, where this line is where the equal sign goes. So to write in row echelon form, we start at the top left corner and make sure this is a 1. In this case it is. This makes our life easier. And then we need to make the 2 below it zeros. So this second row, that's already a 0, so we can skip that and go down to this last row. So to make that -2 a 0, we will replace row 3 with 2 times row 1 plus row 3. So if we do that, our top row will stay the same, our second row stays the same, and our third row is what's going to change. I'll write that in a different color. 2 times 1 plus -2 is 0. 2 times 0 plus 6 is 6. 2 times -4 is -8, plus 3 is 5, -5. 4 times 2 is 8, plus -4 is 4. Now we have a 1 with 2 zeros beneath it. Now we go down one row and over to our first non-zero term, so that would be our 3. We need to make that 3 a 1. So to do so, we can replace row 2 with 1/3 row 2. Then we'll keep the first row the same. And our second row is what's changing this time. 0. 3 times 1/3 is 1. -2 times 1/3 is -2/3. And this stays 1/3. And then our last row remains the same. Now below that 1, we have to make this a 0. To make that a 0, we'll replace row 3 with -6, row 2 plus row 3. Our first row stays the same. Our second row stays the same. Our third row is what is changing. And now, one last thing. We go down a row and over to our next non-zero term, which is this one, and we need to make it a 1 instead of a -1. So we'll just times that whole row by -1. If we were to write this using x, y, and z, we would have x minus 4z equals 4, y minus 2/3 z equals 1/3, and z equals -2. So given these, this is solvable. If we spent the time, we would be able to solve this. So we can conclude that since this is solvable, B is in W.